Okay, good evening all. So I think that still many of you are not comfortable with pointers. So we'll spend one more lecture on pointers and then we'll move on to structures. Okay. So uh, suppose I say int x equal to 5. Basically what happens in the memory, some block is allocated to x and that block is filled with value 5. Okay. So here um, you need to know that x is the name and 5 is the value, right? Now suppose this cell has some address in the RAM, maybe some 200. Okay, I am giving a as subscript to say this is an address. All right, so this indicates address of x, this indicates value of x. Okay, now suppose I say int star p equal to ampersand x. Okay, the same thing I can also say as int star p and p equal to ampersand x. Okay, I can either say it in single line or I can say it in two lines. All right, here you should notice in the second line I said p equal to ampersand x. I didn't say star p equal to ampersand x. All right, so star, except in the declaration statement, if you are using anywhere else, it means dereference. You are dereferencing. All right, only in the declaration statement here int star p equal to ampersand x, here it does not mean dereferencing. Here it is part of the definition of p. Okay, you can imagine it is something like this, int star p. So you are telling the data type of p. P is an int star, int pointer, integer pointer, which means it is holding the address of some integer. Okay, so that is what p is holding. Fine. So then what will happen when I say int star p and p equal to ampersand x? So some cell is created for p also. All right. Now the value of this cell will be the address of x. Ampersand x means address of x. Okay. So this 200, which is the address of x, will become the value of p. All right. So here this is the name and this is the value of p. Okay, now this p may have some other address. All right, that address may be whatever, it can be say 1000 and I'm subscripting it with AA. What it means is this address is holding an integer pointer. 200A is holding an integer. Okay, 200 is the address of an integer, whereas 1000 is the address of an integer pointer. So if you store this 1000 in some other pointer, then you should use not just integer pointer but integer pointer pointer. Right now, don't worry about that. Right now, I'm just saying this cell may also have an address. We are not storing it. Until we store it in a new variable, this will not be stored anywhere. But every cell in the RAM will have an address. That is anyway there. Okay. So this thing is the address of p. All right, so whenever you are dealing with pointers, always make distinction between these two things, value and address. Are you assigning the value or are you assigning the address? All right, as simple as that. Fine. Now what is the relation between p and x? P is a pointer to x. Why? Because the address of x happens to be the value of p. You see this commonality? Address of x happens to be the value of p. Okay, that is the reason we sort of represent this as P is pointing to X. So you can represent it either like this, having two cells, having the address of X and making it the value in cell P. So you can show it like that, or you can, this same thing, you can sort of show it simply like this. You can just say P X, P is pointing to X. Okay, so arrow towards cell X. Actually, in memory, there is no such arrow, right? You can't have such arrows, but this arrow is for human understanding. All right. So it is set to point to X. All right. It is pointing to X. That's why it's called a pointer. But pointer is nothing but another variable which has a value. The only thing is the value of this variable happens to be the address of another variable. That's all. So pointers are easy in one sense and difficult in another sense. They are easy in the sense that they can be explained in one line. A pointer is nothing but address of a variable. That's it. Except this, everything else is difficult. Even though I tell you this line, after this, to deal with pointers, it may be a little confusing. All right. But if you understand this simple aspect, value and address difference, you will understand everything. Okay. So the relation between P and X is P is a pointer to X because the value of P happens to be the address of X. Okay. That's all. That is the simplest relation between the two. Okay. Now, suppose if I say int star Q equal to P. Okay. Now you tell me whether the value of P will be copied to Q or the address of P will be copied to Q. Value of P. Very good. See, it is quite simple, right? Suppose I have two integers, int A equal to B. Value of B will be copied to A or address of B will be copied to A? Value of B. Same thing will apply to anything, whether B is an integer, B is a pointer, B is whatever, same thing will apply. P is some variable. It can be integer, it can be integer pointer, it can be integer pointer pointer, it can be anything. Here I am only saying P on the right hand side. So whatever is in P, that will be copied to the left hand side. What is in P? In this case, what is the number? What is the value of P here in this example? 200, right? So Q, what will come here? 200. All right. So now what does this mean? Value of Q is 200. So what does this mean with respect to X? Exactly. So value of Q also happens to be the address of X. Value of P also happens to be the address of X. So now what will happen? Q is also a pointer to X. Okay. So now I have two pointers, P and Q. P is having address of X, Q is having address of X, X is having some value. It can be 5, whatever it is. Okay. So X address is 200. That address is stored in Q. That address is stored in P. Fine. Now, suppose if I say star P plus plus, what will happen? 200 will be incremented or 5 will be incremented? 200. What will happen if I do P plus plus? Again, I am telling you, star, except in the declaration statement, wherever else you use star, it means dereference. Dereferencing. What is dereferencing? Star means value at an address. P is the address or star P is the address? P is the address. Star P is address only in the declaration. Only while declaring you are saying P is an int star. That's all. After that, whenever you are using, you want to refer to P, just use P. Okay? P's value is the address of X. Okay? So, if you want value of P, will you use P or star P? Value of P. Value at the address is a different thing. Value of P is 200. Okay? That you will use just by using P. Fine. So P will give me 200 or star P will give me 200. P will give me 200. So P will give me 200. Okay? Star P means what? The value at the address 200. Okay? So star P means star of 200. That is 5. Now tell me what will star P plus plus do? Star P plus plus means it will go to the address. It will look at the value of P. It will understand this is an address. It will go to that particular address. It will go look at that value. It will increase that value. Okay. So this is equivalent to X plus plus. Why? Because this is nothing but star of 200A plus plus. Okay. At 200 address, what is stored? 5. So 5 plus plus technically is not correct. You can't use a constant plus plus. You can only use a variable plus plus. But anyway, so at 200 address, you have value of X. So X will be incremented. So X will change from 5 to 6. Okay. But if I do P plus plus, what does it mean? 200 plus plus. But technically, again, this is wrong. 200 plus plus is not correct. But this is like saying P equal to P plus 1. Fine. But again, I told you in the last lecture, whenever you add some integer to a pointer, it will not just add that integer to as a byte. It will it will multiply it with something called scale factor. So here the scale factor is whatever is the size of the data type the pointer is pointing to, that is the scale factor. Okay. So here P plus 1 means P plus 1 into scale factor. So here that scale factor is size of int because it's pointing to int, and that is P plus 4. So it will be 204. 204 means now P will no longer, so this will become 204, which means it is pointing to some address, some location whose address is 204, something next to X. So P will no longer be pointing to X, P will be pointing to this. We don't know what this is. This is outside my program. I didn't initiate that memory. I didn't use that memory, but my pointer is pointing to that memory. So I don't know what is in that memory. If I do star P now, it will print something in that memory location, but I don't know what is there. It will print some random value. Okay. So it may be some random value. I don't know what that is. Okay. But I am able to access it because of pointer, which is a bad thing. But C allows you to do that. This is one criticism of C and C++. Pointers can be misused. That's a different thing. But the advantage is they can be very fast. Pointers are very fast. All right. So this is a different thing you will learn later. But you understand the difference between P++ and star P++? Fine. If I don't put brackets around this, if I just say star P++, what will happen? This incrementation will be done first and then dereferencing will be done. So, yeah, can you close those doors? Can you close the door? So in this case, what will happen? First, P will become 204, okay, and then dereferencing will be done. All right. So 204 is some address, some value may be there. When you dereference that location, you don't know some random value it will print. That's a different case. But if I do star P plus plus, so first dereferencing will be done. So first 200 address, whatever is the value that is there, what is the present at 200 address? 5. So that 5 will be incremented. So the order is important. So this order you will find by looking at the the operators precedence chart, which we used in the beginning. All kinds of operators you have. Increment operator has a higher precedence than dereference operator. So if you don't put brackets, first increment will be done. So pointer will be increased, and then that new location, it will dereference. But if you want this location's value to be increased, you first dereference and then increase. For that, you should put brackets around the star P. Okay, this is clear. And now P and Q are pointing to X. Okay, so let's forget this for a moment. Let's imagine P is pointing to this, and I do star P plus plus. So 5 is becoming 6. Fine. Now if I print star Q, what will it print? It will print 6. Q is 200. Star Q is star of 200. That is 6. Whatever is there at location 200, it will look at that location. It will look at the value present there. It will print that value. So you notice Q did not change X. We changed X using P. But that change is reflected in Q also when you try to dereference using Q. Fine. So it is like more than one pointer, many pointers. Right now there are only 2 pointers. There can be 100 pointers pointing to the same location. All of them are reading the same location. Now it's up to us whether we give write permission to all of them or only to some of them and read permission to most of them, whatever it is. Imagine it's quite simple. It's like sharing some document on Google Drive or some document on OneDrive, whatever it is. Suppose I have a document. I share it with you all. Now, when I'm sharing with you all, there is only one copy of the document. All of you are able to see the same copy. If I give you edit permissions also, even if one of you make changes to the document, everyone else can see that. Okay, so every person who is able to access the document is like a pointer. The document is like the value. So even if one pointer overrides this value, that is visible to all the other pointers. Suppose I don't want all pointers to have write permission. Only I should have the write permission. I will give you access, but only read permission. Still, more than, suppose 1000 people I am giving access, all 1000 people can read, but only I can edit. Okay, so even then, whatever changes I am making, they are visible to all the remaining 1000 people. All right. So imagine these pointers and the value which they are pointing to is exactly like this Google Doc. You have one document which can be seen by many pointers. You're not sharing the copy of the document. It's not like I'm making 1000 copies and sending it to 1000 people. That's what happens when you send a mail. But when you're sharing that's why sharing, it's not copying. So when you're sharing a file, there is only one copy, one master copy. And that same copy is edited by all the pointers. Okay. But if I am making copies and sending it to you all, then your copy is your copy. The changes which you are making to your copy will not be visible to other pointers, right? So that is the difference between pointers and copying. That is what happens when you, in a function, when you pass a variable using call by value and call by reference. When you call by value, it is making a new copy. But when you call by reference, the same master copy, it is passing a new pointer. So whatever changes you are making using pointer inside the function, it is making to the master copy. So even when it comes outside the function, that master copy will look edited. Okay. So this will save a lot of memory, particularly say when you are dealing with large memory data structures like arrays or linked lists or graphs, right? So when you want to do something with an array, you want to pass it to a function. If you try to use call by value, it will copy the entire array and make changes to this copy. That is very inefficient, right? Actually, you can't do that even if you want to. You cannot pass an array by value. We didn't tell you so far. There is a difference when you pass a single primitive data type like integer or char or float, that is passed by value. But when you pass an array, it is automatically passed by reference. It is not passed by value. Even if you want to, you can't do it. That's how it is coded. Okay. So we'll come there. But right now, this much you understood. Fine. So let's quickly code this and see. Suppose I say int x equal to 5 and then I say int star p equal to ampersand x. Again, I'm telling you, when I say int star p equal to ampersand x, only in the declaration I am using int star p. But even there, I am not saying star p, it is int star p. It is still p only. I'm not saying star p equal to ampersand x. I am saying p equal to ampersand x and p is of data type int star. So don't think star p is having the address of x. P is having the address of x. When you do star p, it will go to this address and get me its value. So I can use this star p in place of x. I can use it in RHS, I can use it in LHS, I can use it anywhere I want. Okay. But if I use p in the next statements, it is only address. If I want address of p, then I should use ampersand p. Okay. So always keep this distinction clearly in your mind. A pointer has three things: name, value, and address. Even a variable has three things: name, value, and address. But dereferencing, that is star operator, you can use only with respect to a pointer, not a normal variable. You can't do star x. It doesn't make sense. You can do star p because p is holding an address of some other variable. X is not holding address of any variable. X is holding some value. Okay. P is holding some value, but that value happens to be the address of another variable. So you can go to that address and access that value. But x, the value in x is not pointing anywhere. So you can't go anywhere with this value. All right. So that is the difference. That's why p is a pointer, x is not a pointer. Fine. So star p is possible only to pointers, not to normal variables. Fine. All right. So now, so let me print the value of x. And here, if I want to print the value of x in terms of p, what should I write? Star p. Very good. Star p. The value of star p. And then what I will do? I will say star p. No, first I will say int star q equal to p. Okay. Now I will say the value of star q is star q. All these three should be same, right? X, star p, star q. They should be same. Now I will increment p. Star p, yeah. That's what I said just now. No, if you write ampersand p, it will give you the address of p. What is the address of p? 1000. This p is stored somewhere in the memory, right? It also has an address. That address it will store. So it will give 1000 then. I don't want 1000. I want the value stored at the address, which is the value of p. So this 200 is pointing to x. I should go there and print that value. So that is star p. If I just say p, it will print 200. If I say star p, it will go that side. If I say address, it will go this side. Think like that. Okay, star p plus plus. Now what will happen? When I do star p plus plus, what is happening? X is becoming 6. Star p is x. It goes there and it increments x. X becomes 6. Okay. Now I print all these three. So I'll keep this up. 3. Okay. Yeah. Now initial 3 statements should give me what? 5. Next 3 statements should give me 6. That's it. See, initial 3 statements give me 5. Next 3 statements give me 6. That's it. Fine. Yeah. So this is fine. I can do start p plus plus, or I can also do start q plus plus. Both of them will change x only. Fine. Suppose if I remove this star p plus plus, now what will happen? First p plus plus will happen. So it is going to a new memory location. Now it is no longer pointing to x. Q is still pointing to x. P is no longer pointing to x. It is going to a new location. We don't know what is the value in that new location. It will try to print the value in that location. Okay. So x will be 6. No, x will not be 6. X will be 5. Star q will be 5. Star p will be some random number. Yeah, you see, x is 5. Star q is 5. Star p is some random number. It is pointing to a new location. It is trying to access the value at that location and print that value. That value is some random value. Fine. So the order is changing. Okay, fine. Now, imagine I have an array. Suppose I say or let me not use these numbers. Let me use some other numbers. Okay, say 10, 11, 12, 13, 14. Okay. Now, suppose I have a pointer. Suppose I say int star p equal to, if I want to make it point to the first element of A, what should I do? A of 0 or I'll come there, or in ampersand of A of 0, right? Why? Because again each of these elements has an address. Suppose again I say this address is 200, this is 204, this is 208, 212, 216. Okay, so when I say int star p equal to ampersand A of 0, what will be in p? What is the value of p? Value of p. $200. P is storing the address of A of 0. A of 0 is 10, but address of A of 0 is 200. That is becoming the value of P. Fine. Now if I do star P, it should print 10. Fine. Now, yeah, if I print star P, it will print 10. Now suppose I print star of P plus plus, what will it print? 11. Why will it print 10? Very good. Very good. What's your name? Manashwita. Very good. So technically it should go to next one and print it, but it so happens that when you say star p plus plus, because this is a post increment operator, it will take p and do the dereferencing and increment p separately later. So it will print 10. If I want to make it print 11, what should I write? I should write star of plus plus p. First let it increment and then dereference. Now what will it print? It will print 11. So p plus plus means what? Initially, let me give some space here. Initially, p is pointing here. Okay. When I do p plus plus, what will happen? P will be incremented by 1. P will be incremented by 1 means P will be incremented by 4. So P is becoming 204. So now P's value will be 204. But 204 is the address of 11, right? So P will be pointing to 11. So now when you do star P, it will print 11. Okay? Not star P plus plus, let me say plus plus P. Okay? It will print 11. Suppose if I want it to print 12, then again I should do plus plus P. And then I use star. Okay? That is one way. But I don't, suppose if I want to print 10th element or 11th element, if I have an array of size 100, if I want to print 10th or 11th element, I can't keep doing plus plus every time, right? So by staying where I am, how can I print the 10th element or 11th element? Yes. Suppose in this case, suppose I want to print 12 by not changing P. Suppose P is pointing to 10 only. But I want to print 12 using P. Exactly. You see, one way is you keep moving P. Another way is you keep P where it is. Even when P is wherever it is also sort of having a relative index to each of the elements. Like P is pointing to this. So P plus 1 will be pointing to this. P plus 2 will be pointing to this. P plus 3 will be pointing to this, and P plus 4 will be pointing to this. Okay? Because that is what the number is, that, right? P plus 2 means P address of current integer plus 2 integers address. That will be the address of the third integer. Right? Here the third integer is 12. That will be P plus 2. I mean, the address of 12 will be P plus 2. So I can just say, let me write it here. I can just say print star of P plus 2. Now what will it print? 12. If I say print star of P plus 4, what will it print? It will print 14. Because P plus 4 is nothing but the address of 14. If P is 200, P plus 4 is 216. 216 is the address of 14. So star of P plus 4 will be 14. Okay? Now the same thing you have been accessing in a different way. Right? P plus 4, I can also print as P of 4. P plus 2, star of P plus 2, I can also convert this statement as print P of 2. So technically, star of P plus I is equivalent to P of I. Okay? That is the reason why A of I works. You are using A of I, no, so far. A of 2, A of 3, A of 4, you are printing them using that. But technically what happens at the background, A of I is actually converted to star of A plus I. Because A is nothing but a pointer to the first element of the array. That's the by definition, array name is a pointer to the first element of the array. Array name, the value, if you just print array name, if I just print A, it will print some number. That number is the address of the first element in array A. Okay? So this so if I take A is already pointing to the first element of array A. Okay? So A is having the address of 10. Fine. So if I look at some cell where A is stored, A is having the address of 10, that is 200. Now this is like P and Q, two pointers. A is also pointing to 10, P is also pointing to 10. So you can use either of them. You can use star of A plus 2 or star of P plus 2, or you can use A of 2, you can use P of 2. You can use any of them. Okay. So that is the reason why A of 2 will print A of 2 will print 12, or print P of 2 will print 12, or print star of A plus 2 will also print 12. Similarly, star of P plus 2 will also print 12. All these are equivalent. Okay. Now, because they are equivalent, the funny thing is, you see, okay, before I tell you that, this is, so the crux is you can always replace A of I with star of A plus I. Both are interchangeable. In fact, that is what it is doing at the background. When you are giving A of I, what is it doing? It is converting it into this format, star of A plus I. It knows the address stored in A, value stored in A, which is an address. It adds I integers to that. It increments the address. Now at this new address, it prints the value. It goes to this new address and prints the value. That is what it is doing actually. Okay. So whatever you are giving in terms of indexing, indices, it is converting to pointers and printing it. Fine. Now you will understand why the indexing starts from 0 and not 1. The first element is accessed using A of 0 and not A of 1. Why? Because first element's address is in A. So star A should give me the first element's value. If I have A of 1 as the first element's value, then star A will not give me the first element's value. Star of A plus 1 will give me the first element's value. But that's not what I have. I have A. So I have to get star A, means I have to just add 0 to it. So star of A plus 0 is nothing but star A. That is the A of 0. So indexing should start from 0. That is the reason indexing starts from 0, because in terms of pointers, A is the address of first element. So directly star A should work, which means I should add nothing to A, just 0. Okay. So star of, so let me write like this, A of 0 is nothing but star of A plus 0. That is nothing but star of A. Okay. In this case, that is 10. Fine. All right. Now, an interesting thing is, because star A plus I, because addition is commutative, right? So star of A plus I will be also equal to star of I plus A, right? So I can also use I of A in place of A of I. This will also work. Although array name is A, indexing is some number, some value, some iterator is storing the index. I can use I of A in place of A of I. That will also work, because finally it is converting it into star of A plus I or I of I plus A. Doesn't matter. That is why it will work. If it does not convert like that, it will not work. Finally, it is getting an address. Whatever arithmetic you are doing with pointers, finally you are getting an address. That address it is dereferencing and printing the value. Okay, fine. Now, suppose this P, rather than making it point to the first element of A, suppose I make it point to the third element of A. Okay. Now, if I print star P, what will it print? 12. Okay. If I do star of P plus 1, print star of P plus 1, what will it print? 13. Print star of P plus 2, 14, right? So this is same as printing P of 0, P of 1, P of 2. This is also like an array, but this array starts from the some other element, 12. So this is like a new array, but like an independent array. Fine. So it's not necessary that P should always point to the first element of A. It is flexible. It is something you are creating. You can change it. You can even make it point to some other random thing, not even A. You can make it point to the first element of A, or middle element of A, or last element of A, or some other B, C, whatever it is. You can change P as you want. Okay, so based on wherever it is pointing to, from there, the array numbering of P starts. So P plus 1, P plus 2 will be relative to P, not with respect to A. Fine, this is one thing. Now, the second thing is, here I can either use P plus 1, P plus 2 and then dereference, or I can do P plus plus, that is change P itself and then dereference. But you cannot do A plus plus. A, since it is an array name, it is a const variable. In one of the earlier tutorial sheets which we shared, there is a scope of variables thing, right? That sheet has many other things related to variables. I just asked you to look at the first 3 sections. But in the other sections, you will find this const variable. I can declare a variable while declaring. Suppose I want to declare an integer, which should remain constant throughout the program. Then I can say, instead of int x, I can say const int x, which means later, even by mistake, if you try to change x, it will not allow you to change it. Okay, so an array name is by default a const name. You cannot change the array value. Array name by default points to the first element of the array. If you try to change it, it will lose the anchor to the first element. It will lose the anchor to the entire array. The entire array is anchored on the address of the first element. If you have address of the first element, you can access any element in the array, right? But if you lose this address of the first element, then you have lost access to the array. So you should not change the array name. So the compiler does not allow you to do that. So you cannot do A++ because A is array name. You can do P++ because P is a new pointer which you have created. You can play with it any way you want, but with A you can't play. You can't change A. You can create a new pointer which is having the same address as A and then change that pointer any way you want. But A will always point to the first element. A you cannot change. You can try printing A plus 1 star of A plus 2. That is okay. There you are not changing A. You are using A as it is, and with relative to that position, you are printing other things. But A plus plus itself you can't do. Okay, this is clear. Now finally, when you are passing an array to a function, okay, suppose I say print array function. Okay, this function takes an array and prints it. So it says int a and int size. Okay, and so there's no int, it returns nothing, void. So what does this function do? It just says for I 1 to size print a of I. All right, this is what we have been doing. Fine. So here when I am passing the array, technically what I am doing is I am passing an integer pointer. I am passing the address of the first element of the array. So instead of a with empty brackets, I can also write like this, int star p. So the first element, the first argument to the function is an integer pointer. It is an address of some integer. That address happens to be the first element of address of the first element of A. Okay, so this print array function, I can write it as int A, int size, or int star p, int size, or yeah, these two ways. Okay, or I can also these two ways only, while defining only these two ways. And inside the function you can print using a of I, or you can print star of a plus I. And if you are passing p, you can print star of p plus I, or you can print using p of I use in pseudocode, I use 1. It's only in pseudocode. Okay, so you can use p of I, or you can use star of p plus I. You can use a of I, or you can use star of a plus I, or star of I plus a, or I of a. Anything you can use. And while passing, you can either say int star p, or you can say int p with empty brackets. Both will say both will, in this case, it will work. But star P will also work in other cases. Like you remember the swapping example, swapping by reference. There P is pointing to one integer, it's not pointing to an array. Okay, so even in those cases, you can pass an integer pointer. So when you pass an integer pointer, it's not always necessary that you're passing an array. Fine. When you're passing an integer pointer, it's not clear. You may be passing the first element of the array, or you may be passing some individual element address. Okay, but if you are passing empty brackets, it means you are passing an array. That's the idea. Fine. Even when you pass a single pointer which is pointing to a single element, you can use P of 2, P of 3, etc. But then that will be accessing some random element in the memory. There is no array, but still there will be some cells in the memory. No, it will try to access those cells. So there is invalid access. That is a wrong way of doing things. Okay, so that is the problem there. Fine. Okay, so let's quickly work out some things. This is done. Yeah. So suppose I have an array a of 3 equal to 1 to 3, and then I say int star p equal to ampersand a of 0. So another way, like she was saying, if I want to, okay, first let me just run this. So I'm giving the address of the first element to p, and then I'm printing p of 2. It should print what? 3. It should print 3. I can do a of 2, I can do p of 2 because both are pointing to the first element. It printed 3. Fine. Now, suppose instead of saying ampersand a of 0, I can also write a, because ampersand a of 0 is nothing but address of first element. That is also the value of a itself. So I can just say a. This will also work. Same thing. Fine. I can also say star of p plus 2. This will also work. Fine. Let me try giving 2 of p. I never tested so far. I know if it is a variable, it will work, but let me see if I give a constant, it will work or not. Okay, it works. Because it is converting that to star of 2 plus p. That's why it works. Fine. All right. This is clear. Now if I do p plus plus, okay, I do int star p, and then what I do, I say, okay, so in the first statement, what will it print? Print star p 1. Then I did p plus plus, and then I'm again printing star p. What will it print? 2. First it is pointing to first element, it will print 1. Then it is becoming p plus plus. Now p itself has changed. Yeah, p itself has changed. So now I'm printing p star p again, it will print 2. Okay, fine. All right. Now this is a function definition, print array. I am passing a integer pointer. Fine. But I'm assuming I'm passing an array. But I can't pass entire array. I can only pass the address of the first element. Fine. So I'm passing integer pointer and size of the array, and I'm running through the array and printing each element in the array. Fine. I initialized an array a equal to a of 5 1 2 3 4 5, and I'm passing the address of first element of a. So rather than ampersand a of 0, I can also write a, just a. That will also work. Both are same. Fine. So it just prints 1 2 3 4 5. Fine. Now suppose if I pass a, it will work. Okay. Now suppose instead of a or ampersand a of 0, If I pass ampersand A of 2, will it work or will it give an error? Yeah, it will work. It is only giving the address of 3 as input to the function. So now for P of 0 will be 3. P of 1 will be 4. P of 2 will be 5. And after that, some random elements. Okay, so let's see. So it will print 3, 4, 5 and 2 more random elements. 3, 4, 5 and some random values. Okay, because you are passing the address of third element to the function, that will be the first element for that pointer. Okay. Yes, we can't. That is why we should not lose. We can get values of 1 or 2. 1 or 2 if we do P minus minus. But I don't know. We can do star of P minus 1, star of P minus 2. Okay, P of minus 1 like that you are saying. Let me check. I'm not sure if it will work. It may work in Python, but so okay. Let me try it in the other program which we checked. No, 7. So suppose I say star P equal to ampersand A of 2. Fine. Now here I say P of minus 1. Okay. So it should print. What should it print? It should print 2, right? Yeah, it's working. Simple, it is converting it to star of whatever P plus I. I see some blank faces. I don't know why it's difficult. When I'm saying star of P equal to ampersand A of 2, it is storing the address of 3 in P. So when I do P minus 1, it will give me the address of 2. So P of minus 1 is star of P minus 1. So it should print the value. Okay, fine. All right. Yeah, still there is a lot to pointers, but we'll see. This is for basic. You understood pointers for individual values, pointers for arrays, pointers when passed into functions. I hope you got an idea. So you should be able to solve this week's assignment. Next class we'll start structures. Next week we have 2 classes. Okay. In those 2 classes, again, 1 class will be structures, and then remaining class I will cover some things which I missed in the previous classes. Whatever I want to cover, some things miscellaneous. Okay. All right.